volume numbers are ticking up, so I'll do a sort of soft start on this. So good morning, everyone, and thank you for joining our second Rescue Network webinar. So we'll be discussing industry perspectives on the circular economy today. My name is Kerry, and I'm a sustainability engineer at the Offshore Renewable Energy Catapult. So just to quickly run through the agenda for today, so we'll start with a really quick recap of the rescue project for anyone that's not familiar, before moving over to our industry speakers, Bill Firth from European Metal Recycling and Thomas Kelly from Ionic Technologies. Following these presentations, we'll open up to a Q&A session and then move on to wrap up at the end. A couple of bits of housekeeping before we get started. This session is being recorded and will be available to view afterwards, along with the slides. We'll also be using the Q&A function in Zoom for questions, so please do share your thoughts there throughout the session and we'll pick those up towards the end. So just to get us started, I'll give a quick overview of Rescue. So the Catapult leads the Rescue Regulatory Science and Innovation Network, which is exploring opportunities to increase circularity in the wind industry, with a particular focus on the role that policy and regulation can play in unlocking innovation across the UK supply chain. So as part of our work, we've been gathering evidence and insights on the circular wind landscape, and our academic partners have been carrying out a range of stakeholder engagement activities, which I'm sure some of you have been involved in. So these include regional workshops, regulatory forums and roundtables, and targeted case study interviews to really understand the landscape and what we're seeing in practice at the moment. One of the key emerging themes that we've found throughout our work is the need for facilitating knowledge exchange and increasing understanding of the innovations and approaches that are being explored for circular wind. So I'm delighted to be joined today by two of our industry partners on the project, EMR and Ionic Technologies, who are both pioneering in their work in the circular economy space. And I'll first hand you over to Bill Firth at European Metal Recycling to talk you through some of the opportunities that EMR see in this space. So Bill, over to you.
Yeah, thanks very much, Kerry. Good morning, everybody. Just a bit of a health check. I've got quite a lot of click-throughs on this presentation, and Kerry is remotely piloting, so hopefully we'll sync it as best we can. So what I'll look to do within the presentation today is just give you a bit of a view on what we're doing at EMR, particularly within the UK and our wind and renewables business unit, but then also get into some details around some of the actual practicalities where the activities are actually meeting the regulations, and our view on how actually we believe the regulations can be enablers to circular solutions. So yeah, we'll click onto the next one, please, Kerry. So just a bit of background to EMR. We're one of the world's largest mixed metal recyclers. In the UK, we'll process and recycle about 4 million tonnes of metals every year across 65 facilities. And what we decided to do in 2024, with the support of Innovate UK, was to take one of our sites and partially convert that into a wind turbine processing centre in Glasgow, which has been really good and really helpful from a sort of learning perspective that we're now taking into projects where we're looking at bringing in turbines and actually forensically dismantling those turbines and making parts and materials available for resale, reuse, looking at repurposing options as well, and all of those materials and components that you can see on the right hand side. We've currently got active circular solutions for all of those. You might see on the tower it says concrete. We haven't had any concrete towers yet in the UK, but we've had one or two in our US business actually, so that's been interesting receiving those units. So yeah, on to the next one, please, Kerry. Yeah, so just a bit of a sort of overview as how we treat end of life for wind turbines. What we apply is what we call our material management pathways. I'll give you a brief sort of run through of these, and then on the next slide, slides thereafter, I'll go through how we're seeing the regulations into play. So what we do first of all is look at whether we can actually resell the whole asset as a complete turbine, and we're quite fortunate that because we work in Europe as well, we've got quite a bit of experience of working with partners who have been doing this quite a while. So we understand that process very well now. Then we've got, you see, stage gates in there, pass fail. So if we believe we can't sell it or there's no demand for it, we'll move into pathway 2, which is really around parts recovery, major and minor components, moving through to the tower and blades. And again, after we've exhausted all those opportunities, we'll look at pathway 3, which is recycling. And then that's where we'll look at taking it back to the individual, to the metals, including rare earth element. And Tom's going to pick up on that in some detail. And we're actually working with Tom on quite an interesting project around rare earths, actually from magnets, and then looking at increasingly composites and glass fiber. And then the right hand side, you'll see that fail arrow. So we try not to get to that point, but we do appreciate in certain circumstances we may have to look at recovery options as a sort of next pathway. Yeah, so what we're finding as we sort of move from through these is that we definitely need earlier engagement than traditionally what we have had as a business. So if we are to explore pathways 1 and 2 particularly, this can take quite a lot of information over quite a period of time before we get to a confidence level where we can actually put those processes into place. But what we do know and what we have seen is that they have the ability to create significant additional value where we can do this. And so if you include that within the life cycle of the project, again, engaging early, we believe it's a huge efficiency win there. And again, really importantly, shouldn't lose fact that, we've got the ability to save lots of materials, lots of carbons by implementing the various pathways. Yeah, so just looking at sort of pathway 1 and how we see this working in a bit more detail. So Kerry, if you just click through, that'd be great. Yeah, so our sort of view on this, and again, please take your own advice. What we've seen here and what we've sort of established and become quite comfortable ourselves is that turbines that can actually get to the point of being resold never become a waste. That's evidenced through quite a detailed sort of multi-stage process that we have in place with various buyers for turbines who are experienced of doing this. And this is really about evidence around operational hours, when the turbine was installed, the type of turbine. We're finding that certain turbine types are much more appealing on the market, a bit like second-hand cars in sort of many ways. But we've got a clear sort of system there for how we'd extract that evidence to understand whether the turbine's available for resale. And as I said there, we think that remains a product at that point. So if we move on to pathway 2 and just focusing on that for a minute, this is where we're looking at the parts recovery. This is, where we're seeing a bit of divergence here in terms of reusable parts. Again, it's for us, it's about the evidence base that we're developing quite a network and ecosystem of suppliers that want various parts from us. People are at Renewable Parts in Scotland. We work with those really closely. Other companies looking at braking units, yaw gears, electrical panels as well. So they effectively give us a criteria list for initial assessment. So again, even while the turbine is still standing, we'll be looking to try and extract the evidence from the asset owner where possible to actually put that out to our customers to actually see whether we can create reusable parts. And again, if the reusable parts are reusable in their current form, again, our view is that they remain a product. They don't fall into the definition of waste. But slightly following on from that, if we get into the point where we're looking at the sort of what are the next categories of repurposing. So this is a good example would be looking at taking blades and converting those into various sort of street furniture applications. We're working on the basis that those blades coming into us have been originally discarded, can't be reused directly as a blade in relation to repurposing, and therefore we'd have to go through an end of waste process. But we actually think that's relatively achievable. We think the pathways are there. to do that. And again, because repurposing is going through a waste management activity, we would undertake that on one of our permitted waste facilities. So if we look at pathway 3, which is, we'd probably say the more traditional, more established pathways which are available to us. In terms of recycling, we're treating all of those materials at that stage as a waste in terms of duty of care. But actually what we're finding then is that those materials, and I believe there's quite a few manufacturers on this call who take materials from us. Some of those take those materials still as a waste from us. So a good example are the sort of ferrous and the non-ferrous metals that we recover. So we supply those, move those as a waste. The mill, for example, is permitted. And at that point, they'll undertake the final conversion. But what we also do actually with quite a few of our materials is we actually achieve end of waste, particularly around the metals. So we actually move those as products under established protocols. So we go through a full life cycle of taking those back to products. And I know that we're actively working with Tom on sort of end of life, on the end of waste route maps for rare earth elements to be able to unlock the value in sort of secondary uses. So I think just kind of summarizing the pathways really, you can have sort of various options. So Kerry, if you just click through, please. Yeah, you can have, we're finding this on various projects pretty much all the time. We're looking at various different scenarios. You can have some, might be a wind farm with 10 turbines, 3 might be available for sale, 4 might be recovery for parts, 2 might have been fire damaged. So I think it's important to sort of understand that, that you will encounter, or we're certainly encountering different scenarios, and all of those can be sort of baked and built into the same plan. So as I put there, some materials remain as products, some become wastes, some waste become products. And I think having that early understanding in the project and the ability to actually implement and deliver the plan allows you to sort of put those pathways in place. So just last slide from me. So yeah, I mean, it's interesting. We've been having lots of discussions on the rescue project about regulations. Do we need more? Do we need less? And I think our view is that the pathways are there and they are available to achieve circular outcomes, going through reuse and repurposing and taking waste back to products, but also managing materials within the waste framework as well. The Waste Framework Directive is a very mature piece of legislation, and we've actually retained the 2020 version of the Waste Directive framework post Brexit. And within that directive, they're very clearly laid out what you need to do to sort of manage these materials to actually achieve end of waste products. So I don't think it's a complete mystery what you need to do, because the information is there and available for everyone to see and understand. But I think what we've learned over the years is that you need time, you need to plan this, you've got to look at engaging early. And then within that, what does that overarching circular plan look like? What are the intentions and the ambitions of the project? Once you know that, you can actually then start to actually work through the pathways, put those forward, and then decide what you're going to do, and then try and secure the evidence and make sure you have that in place before you can actually put those into place. So you've de-risked from a compliance side, but you've optimized from a value side. And then in terms of, some important key stakeholders in there, you've got the regulators, we've got local planning authorities, you've got local communities. And again, our view is that a lot of this can be done by businesses, by understanding the regulations and then reaching out to those organizations really to get a sort of a sense check rather than an ultimate validation really. And that's the sort of way that we've been going to do this. And I think we've been doing it, and I think it's worked well so far. But I think ultimately, I think the last thing is, I think it's really hard to force circularity onto project. Unfortunately, we're transitioning to a circular economy. We'd still built materials which are very, very difficult to actually do anything other than recycle at this stage, but we're actually learning quickly. But I think once we show the added value within the project and maybe some extended time, but in terms of the overall return, that can often be higher. And then that's, I think, how we'll see circularity scaling quickly across the wind industry. So that's it from me. Thank you. And I think we'll take questions at the end along with Tom. Thanks, everybody.
Thanks, Bill. That's brilliant. Thank you. Yes, as I say, please keep adding questions into the Q&A, and we'll pick them up in the session after the next presentation, which gives me the opportunity to hand this over to Thomas Kelly from Ionic.
Thanks very much, Kerry, and thanks for the opportunity to speak today. I think one thing that Bill ended on there that I think chimes very true with our business is for circularity to scale, we must show how regulation can create value. And that's absolutely the case in our business. We are doing something pretty novel and new and different with respect to rare earth permanent magnets. And this is part of the reason why we got involved in the rescue project, was to understand the regulatory space that we look to exist in and how we can interact with groups like EMR in order to deliver our vision, which is for a circular economy for rare earths. So if you can click on, Kerry, to the first slide, please. Just for anyone who doesn't know what our business is and what we do, we are what's referred to as a long loop recycler of rare earth permanent magnets. So wind turbines obviously contain magnets, as Bill alluded to. Our process, by definition, enables us to recover rare earth oxides, which are the building blocks for almost all modern technology, where there's a rare earth permanent magnet in electric vehicles, MRI scanners, AI robotics, defense applications, and of course, offshore wind turbines. Where magnets are present, we can extract them and work with groups like EMR to get the magnets out. And we present ourselves as quite a flexible intaker of material, because magnets are very susceptible to contamination, they're very susceptible to oxidation. The ability to recycle them can be inhibited by them being oxidized, so becoming rusty or being broken up. But we can take magnets in more or less any condition and recover from them the separated rare earth oxides. So the material that everyone is talking about at the moment, and you hear it in the news, and all the activity around Greenland and Ukraine and all the rest of it. The reality is that long loop recycling represents the quickest route to get this material back from end of life application and reuse it in the next generation of motors. So the material that we produce is an oxide powder, like that stuff in the middle, which is a very desirable product. And that particular stuff that you can see, the yellow powder, is dysprosium. And right now, 100% of the world's supply of dysprosium currently comes from China. So the appetite for an alternative supply chain is growing almost by the day. If you can click on, please, Kerry, I can explain just in terms of a wind setting, just why this matters so much, and also something that's come along during the course of the project, which is a significant update, which not everyone necessarily is clued in on just yet. But within something like a wind turbine, you obviously have rare earth permanent magnets, as we know. On the top right, you can see the sort of typical makeup of a high specification rare earth permanent magnet. About a third of the mass is rare earth, so that's your neodymium, praseodymium, dysprosium, and terbium. And in a typical wind turbine, you're looking at around 200 kilograms of rare earths per megawatt of power. So, for some of the larger wind turbines, we're talking ton volumes of material required in order to produce the next generation of offshore wind turbines. And what's happened recently in 2025, the critical mineral strategy was launched by the UK government. It was owned by the Department for Business and Trade, and EMR and Ionic and a number of other groups in the space have all contributed towards the development of that strategy. The government is committing to ambitions to produce 10% of domestic critical minerals within the UK by 2035, and then 20% target on recycling. So just those two items alone are telling us that UK government policy now dictates or drives the need to incorporate recycling into the supply of new products. And in the case of rare earths, there's a really active market within the UK. So it's an obvious area of strength that we can look to develop. And then the other key item there is limiting dependence on a single third nation to 60%. So when I tell you that terbium and dysprosium are globally 100% supplied from China, that is quite a significant ambition to try and achieve. So all the stuff that we are doing at Ionic Technologies is very coherent with the strategy. And we see regulation around this space as an opportunity to enable those targets to be reached. So if you skip on ahead, Kerry, to the next slide, just to give you an idea of our market, this is what it looks like in 2028. So around 70,000 tons of rare earth oxides will be required globally by 2028. And the bars on the left show you what the shortfall is from this is all Western data, so non-Chinese data. So ex-China demand for processed rare earth oxide materials, which is where we sit, has a 54,000 ton deficit. And that's a global problem. And this is why there's so much focus on this whole area at the moment. So there's more and more groups coming online that can process this stuff. But as I alluded to earlier, long loop recycling of rare earths is so attractive because we effectively short circuit the need for mining. We won't replace mining. The volumes required are too high for that. However, in terms of a sort of rapid solution that provides access to material, that's where we sit. And then recycling makes a lot of sense because in rare earths, when you mine the material, you typically get up to 17 elements all at once out of the earth, where you maybe only want 4 or 5 of them. So by recycling, you're only handling the material that you actually want to recover. In addition to that, the capital involved in building a recycling facility, we think of as being prohibitive in the West, but in reality, it's significantly cheaper than building a mine. So there's a number of reasons why long loop recycling makes sense. So if you skip on, Kerry, to the next slide, I can explain what we've been doing over the last few years. We've grown pretty quickly from a laboratory at Queen's University in Belfast through a series of scale-up de-risking projects to where we currently sit in the Drive 35 Collaborate project, which Bill touched on a little earlier, and I'll give a bit more info in a second. But because of the ability to produce every grade of rare earth oxides, we have a natural synergy with the automotive sector and the wind sector, which require high-end magnets. So we focused primarily on those industries as areas where we can provide a circular solution. And the next stage of our growth will be to build a commercial plant, which we believe we can deliver in around about 2 years. And obviously, a big function of that will be how we obtain material, what the material is classified as, what our site needs to be classified as, how we manage all of that stuff. And that's part of the reason, again, why we got so involved in the rescue project, because we saw it as an opportunity to understand the environment a bit better and figure out how we can work with front-end scrap handlers like EMR in a way that works for everyone. So if you skip on to my next slide, please, just to show you how our process works, a bit of a flavour. We bring magnets in that may arrive potentially arrive as a powder, or they might arrive magnetized, demagnetized. In the case of wind turbine magnets, they have to arrive demagnetized realistically because they're so incredibly strong, powerful, and hard to handle. Leave that to the experts at EMR. We then take that material, break it up, digest it. We produce a mixed rare earth oxide, which in itself is something that potentially could be traded as a product. And then we separate that, and it's that separation process that we patented, and that's really our expertise. So I think one thing I want to sort of highlight here is that our expertise as a business is the technical process that we have and the knowledge to recover rare earth oxides as efficiently as possible. And we want to obviously sell those oxides into a downstream supply market that needs them. The waste handling element of it would not be necessarily our speciality. And again, that's why groups like EMR make a lot of sense for us to work with. And then if you skip on, Kerry, to my next slide, I want to explain from a kind of holistic level, why this makes so much sense to do what we're doing. So a typical supply chain for rare earths from mining through to magnet generates a lot of environmental issues globally. So obviously, in a typical UK setting, we don't see a lot of this because we just buy magnets or we just buy a wind turbine. We don't buy rare earths or consider the impact that they represent. But if you mine material out the ground, you're generating massive amounts of toxic wastes for every ton of rare earths you generate. Wastewater, radionuclides, sulfur dioxide. And right now in the West, our recycling rate for rare earth permanent magnets is about 1%. So all that embedded environmental harm, if you like, is all lost whenever these materials come to end of life. What we are looking to do, obviously, is to replace that activity with our process. And if you skip on, Kerry, I can give a very objective view of the impact that it makes. The life cycle analysis work that we've completed with Minviro indicates 61% reduction on dysprosium oxide and 53% reduction on NdPr oxide. And that's versus the foremost sources of these materials from mining. So for any manufacturers of equipment, that's an instant scope 3 emission benefit that is achievable by using our product. But obviously, from a global perspective, there's all that radioactive waste, gas generation, et cetera, and then, of course, retention of a finite resource is all saved by using a long-loop recycling process. So if you jump on to the next slide, this is the kind of primary example that Bill alluded to, which is our CREAM project, the Circular Economy project, which we've created for the automotive space, and worked with a number of OEMs in that space in order to provide a circular solution and what that would look like. And obviously, this is very coherent with government policy, and we've been supported quite healthily by the Advanced Propulsion Centre to deliver this project. But the idea is quite straightforward. We put the rare earths just through a supply chain and provide that traceability from start to finish. And EMR are leading a significant chunk of work within magnet liberation to find the most efficient ways to recover magnets from EV motors. It's a totally different ballgame handling wind turbines, obviously. The scale, the challenges, the safety implications, etc. But the principle is pretty solid in terms of putting that material back through the downstream supply chain. And we've demonstrated that and are continuing to demonstrate that with some of the highest specification of magnets that are needed for automotive application. And within that group, BGS are providing a full supply chain LCA as well as an economic analysis, because price transparency as well as material transparency in this sector is very challenging. If you skip on, Kerry, in an ideal world, this is what it could look like in wind. So very similar, we take the material in at the top of the tree and we put that through the downstream supply chain, through magnet making and into wind turbines. And then at end of life, the material is liberated by EMR, and we can potentially put material back through that supply chain indefinitely with a good system for transparency and a regulatory model that matches. From a commercial perspective, stability on price is a big deal here, because right now the whole market is driven by the Asian Metals Index, which is a metric that none of us have any control over. So there's a potential here for some sort of system, ecosystem for circularity that has limited exposure to an external pricing mechanism like that. And if you skip on to the next slide, we've within the rescue project, this was the aim of the game. This is why we wanted to do this. We wanted to understand what sits north of those two white lines and where magnets are going to sit within existing regulation, and whether we think there's anything within existing regulation that could aid and make a circular economy for rare earths more achievable. So the project itself was, I mean, I'm sure Kerry and Lorna and the rest of the team can talk for hours about the sessions that they've run. But obviously there was a significant review of existing regulations, which yielded hundreds, I believe, of potentially applicable regulatory measures that could exist in that space. And there was a number of interview studies done across regulators, academia, businesses to understand what we think is necessary for managing material end of life and all the end of waste regulation as well. And there was a keenness really to encourage the supply chain to interact and make those early contacts to understand the needs from one party to the next. What's happened since we started the rescue project, as I said earlier, is the critical mineral strategy has been launched. So in our space, where we drill down into rare earth permanent magnets, there's now a policy within government to enable all this to happen. So, something that will follow from the announcement around critical mineral strategy is probably a review of regulation from within governments to ensure that those targets become achievable. But our interest in the project, I think we're really to ensure that regulation is used as a tool to retain material in the country, so we don't lose it and it gets exported and we lose all that economic value and material itself. The traceability is something that is always of interest to OEMs particularly, but across the supply chain. The potential for emissions reduction likewise. And that retention of material represents a security opportunity as well, because the dependency on China in this space for all Western countries is something that's being looked at right now. And then the last thing was a sort of generic requirement to de-risk the scaling up of our technology, but every sort of scaling technology, and this is something that I was quite pleased to hear Bill mention at the end of his presentation as well. I mean, that's ultimately what we need to be able to do, and we need to ensure that the regulations fit with that, and that's where the project came into being. And if you skip on, Kerry, please, the next slide. This is what we're aiming to do, is to build this commercial scale facility. So where we sit at the moment in Belfast, we have a 10-ton per annum rare earth oxide facility, which is our demonstrator plant. It's an advanced pilot, I suppose you would describe it as. And we want to build a 400-ton per annum commercial scale facility, which can accommodate the surge of magnets from across industry, but particularly from the wind industry, which is expected from 2030 onwards. And the way that the UK market exists, a lot of that material will be handled by EMR. We think we can produce material at a rate that's less than $30 per kilogram of rare earth oxides. When you consider that when we started the feasibility study for this project, the NdPr price, which is the biggest product that we're going to make, was around about $50 to $55. It's now set at $123, and that's changed in the space of about a year. So it really opens the door in terms of how much material we want, but also our ability to buy magnets from EMR for us to be able to recycle. And that's the key bit in this, is there has to be a regulatory environment that enables a commercial relationship for a business like ours to be able to buy our feedstock material. So despite the fact that I've kind of been politely moaning about our dependence on China, the AMI has actually done us a bit of a favour in this regard, in that we can probably pay a bit more for magnets now. But it stands to reason, because the value of the material we can sell goes up. So if we could just skip on to the next slide, in summary, that our technology enables this traceable route through a circular supply chain. It's the unlock for material at a high enough grade that you can continue to make high specification magnets, and that's why we want to buy end-of-life magnets from EMR in order to do this. The rescue project really favoured the analysis of regulation in the environment that we're going to sit in, and the market that we find ourselves in has changed significantly since we started the project, and the appetite for moving this ahead quickly has grown from a business perspective, but also from a UK government perspective. I'd like to wrap up by offering up a big thank you to Lorna, Kerry, Anne, and the whole team within Rescue for the amount of work that you've done on this, because really the role that the EMR and Ionic have played in this project is to provide steering and influence and needs and wants and give a long list of questions. But you were always the ones providing the answers, and we were the ones providing the questions. So big thank you for that. That's everything from me, and I hope that that's a whistle-stop tour around the rare earth market and what we're doing within it, and how all this fits in with Rescue. So thank you very much.
Thanks, Tom. That's greatly appreciated. So I think next section is looking at the sort of Q&A. I can see there's a couple of questions already in the Q&A function, so please do keep adding them in there, and we'll try and get through them as we go along. So I'll just go in sort of the order that they've turned up here. So the first one I've got here is for Bill. In your business model for turbine resale, does the owner see some benefit when the turbines are sold for reuse?
Yeah, I think the short answer is yes. On that one, what we're starting to do now on projects is to move more towards a sort of asset management type role. So when we're actually feeding back into sort of quotations, is providing a range of values based on different scenarios, from resale to parts recovery to recycling. That does take more time, but we absolutely believe that we've got to create the maximum amount of value to be able to share with the asset owners, and in turn that enables the supply chain to scale. So yes, we'd be looking to share the additional value from resale. I think just sorry, Kerry, just another thing that just strikes me as well is that I think what we're finding with the circular economy as well, not only are the sort of activities changing, we're finding that business models are sort of changing, and maybe for the better as well. So we're actually considering, and we do this already in certain circumstances, is just providing recycling as a service where we don't actually buy or take ownership of the commodity. That actually stays within the ownership and use of others, and we just undertake the recycling to make the materials available for others in the supply chain. So again, it's interesting to see those sort of options being sort of implemented now, as well as the sort of very traditional models.
Brilliant. No, that's really interesting. Just picking up on the second question, I think I could probably answer this one myself, is around whether tidal stream sector has been involved in this work. The answer to that is no. At this point, it's been focused on both onshore and offshore wind. However, the regulatory databases that have been pulled together are likely to be applicable to tidal energy. So there might be a piece of work looking at how you could adjust that to look at different sectors. But at the moment, the focus has been on wind specifically. So I'll just
I mean, Kerry, just on that one, if you don't mind, I'll just jump in here. We've actually just been approached by a tidal energy developer. They've actually come to us in terms of decommissioning plans. So that's really interesting. So we're looking at that now. And I think exactly as you said, I think from our perspective, the pathways will be the same. So yeah, we'll feed that back through into the project as well.
No, that's brilliant. That's good alignment on timings there. But yeah, as I say, I think a lot of it should be applicable. And of course, because we've been looking at offshore wind, there are aspects of that will be very transferable to other sectors that are relevant on that. So for the next one I've got here is for Tom. So what are the largest contributors to the carbon footprint of virgin rare earth element processes, and there's ionic technology process, and where is the reduction coming from?
Yeah, it's a good question, that. So the core process that we use is, when you think about it, we're dealing with a smaller group of elements, right? So we're dealing with neodymium, praseodymium, dysprosium, and terbium. So 4 rare earths that are usually found in magnets. For mining, they don't occur naturally like that. So in a mining space, you're dealing with a much bigger group of elements that you need to then go on to separate, and maybe only a small fraction of that is what you really want from the sort of base material. So the economies of scale are lower. In terms of the amount of work required then to separate is reduced, and in addition to that, you obviously have a number of kind of accretive benefits from doing this outside of China. So you've got an environment where the energy market is more renewable orientated generally. You've got chemicals that are manufactured in a way that's again less carbon intensive. Plus, we use more sustainable chemicals anyway. So there's a number of different factors that kind of build towards that. From going through the process of developing an LCA for our process and then trying to compare it to primary material, the hardest aspect, to be quite honest, was finding some reliable comparator data. because at the moment all of that is being developed via mines that already exist, and most of that volume is coming from China. So finding reliable sort of comparison data was a difficult part of that process. What I would say is that when we finished that process, Minviro, who we partnered with, published a very similar report that they did with Apple about 6 months later, which found almost identical results in terms of those two chemicals or two products, NdPr and dysprosium. So it's very consistent with what they found. And yeah, we think we can get that lower. I think this is a key point. I mean, the system boundary that we operated in was for rare earth oxide production. But obviously, if you put that material back through a European supply chain, in theory, you get a compounding effect on things like energy required and all the other inputs that go into making magnets. We think we can make that scope 3 emission at the OEM level a lot better. But from our perspective, the area we can control is the oxide. So the project that we're doing with Bill and the team at EMR for the automotive sector will actually provide a more holistic estimate for the embedded CO2 in a European produced magnet, which again we'll try and compare to something equivalent from China and see if that number creeps up.
I think that's really interesting. It also sort of leads into the next question around actually how much waste is produced during the process that you're using at Ionic, and whether the solvents can be reused multiple times. I suppose outside of those carbon impacts, what are some of the other impacts that you might be seeing?
Yeah, that's right. That is correct. So the solvents that we use can be used multiple times. They don't last forever, and we lose some of the solvents along the way in small volumes. But broadly speaking, they can be reused, which makes the process very efficient. In terms of wastes, what we end up with is just the iron from the magnets and derivatives of that. So it's pretty inert stuff, really. For the time being, the answer to the question objectively is yes. For one reason or another, the UK, going into this recent period of whatever you want to call it, rare earth interest or crisis or whatever you want to label it, the UK was very well positioned actually, because less common metals is one of, if not the only, metal and alloy manufacturer for rare earth alloys outside of China, and it happens to be an Ellesmere port in England. So they have a facility that's been there for quite a long time, churning out strip cast alloy and other products that are essential for magnet making. And for us, objectively, that is an obvious off-taker for our material. Obviously, in the last couple of years, with all the interest around this, that the market has grown significantly in the UK and in other markets as well. In Europe, for instance, there's a massive demand for the material that we produce, and there's very, very few producers of it. But there is a desire within the Critical Raw Materials Act in Europe, similar to the UK, to target high recycling, so 25% recycled material, for example, which obviously we can participate in. But the market outside of the UK is growing significantly, and right now we're being asked how much can you produce and when can you sell it to us, which is something we're limited by in terms of the demonstration plant capacity. But there is definitively a growing market for it. Just to stick a number on that as well, if you want one. For example, wind turbines, there aren't a lot of wind turbines manufactured in the UK, but in the automotive space, there is definitely a OEM manufacturing presence with Ford and JLR and others. So the Advanced Propulsion Centre estimate that by 2030, there'll be around 2,500 tons of magnets required. So in our space, that equates to around about 800 tons of rare earth oxide equivalent. That's just for EDU, so that's just for motors. So the market is definitely there in the UK. The supply chain is complicated, but fortunately, there is a really strong presence in the UK for alloy making and hopefully in the future in some form magnet making as well. In that case, the UK will have the entire supply chain onshored, which is a unique proposition compared to the rest of the world, really, at this stage.
No, that's brilliant, and also I guess shout out to the Climates program for really helping to develop some of that supply chain and innovation in that
Absolutely.
space. Yeah. So moving over to some questions, I think to yourself, Bill. I might try and link these ones together. So there's a question here around who is buying secondhand turbines and what that market looks like, and I guess do you see a difference in the opportunity for resale offshore turbines versus onshore?
Yeah. Take the first one first, Kerry, and then come into the second one. Yeah, I mean it's quite interesting actually. The secondhand turbine market. We've seen quite a few different groups and organisations that are interested. So they typically range from you have platform businesses that will look at buying and selling secondhand turbines. So you can log on today and see which turbines are available to sell. And then I think what we're also finding that's becoming quite interesting is quite a few developers now are actually building business models around using refurbished, near end of life turbines. Mainly because what we're seeing is that not only from a sort of economic reduction in capex, but with the sort of smaller size units. So we've seen a lot of OEMs sort of really move towards developing 5 megawatt plus systems for efficiencies, and there's a bit of a gap in the sort of smaller 2-3 megawatt systems and where developers see restrictions potentially around planning. So that's been quite interesting. But also community groups are looking at. We've had quite a few approaches from community groups looking at sort of cost-effective second-hand turbines, and again, these sold with a warranty based around provision of sort of performance metrics, and some small industrial companies as well looking at taking these in. So I definitely think the market's growing actually. And then in the terms of the next one question from Scott's really interesting actually. I was just scratching my head thinking about that when that came through. I think it'd be a sort of fascinating scenario to actually model. I suppose what sort of jumps out maybe sort of straight away is a sort of different economies of scale needed for offshore, and the sort of offshore we decommissioned an offshore wind turbine just at the end of last year in the UK, and that was only a 2 megawatt turbine. It was an onshore turbine that had been actually commissioned offshore. So I think the first generation of offshore turbines will actually probably see resale potentially back more for onshore, and then going forward a sort of the sort of the engineering required to maybe move a sort of 10 megawatt turbine and reuse and reposition could be interesting. And are we going to be at the point of 25 megawatt turbines at that stage, and the cost of capital? And yes, it's a fascinating question, Scott. I think that's definitely one to sort of keep thinking about. But look, yeah, we'd be happy to sort of we like to model different scenarios and then come up with some answers.
No, that's really interesting. I was just gonna jump in there and ask, on that first question of where you're seeing the resale, are you seeing that predominantly sort of in the UK, or is it sort of more European spread at the
It,
moment for that market?
it's both. I mean, to be honest, the sort of initial interest was Europe. Europe's sort of way ahead of us in terms of decommissioning. I speak to my Dutch and German colleagues, and they kind of roll their eyes at me when I start talking about decommissioning. As it's new and exciting. They've been doing this for kind of 10, 11 years now. So you've got quite a lot of established players in that market, and obviously they're sort of and Brexit hasn't really helped in many ways with them coming into the UK. So we've been a bit of a bridge into that. But it's great to see some sort of UK interest as well in second-hand turbines. And we spoke to a developer recently, and their model was just to buy second-hand turbines, and they were offering that as a sort of value add within their power supply agreements.
No, fab. That's really interesting. So, I guess last question we got at the moment in the Q&A from Jonathan is, it's good to hear that you think the regulatory environment is supportive. What do you think could be improved to further support increased circularity in the sector? And I imagine this is to both of you. I don't know who wants to take it first.
I'll jump in first if that's all right. I think that one of the sort of I suppose, I don't know if it's an intended or unintended consequence of kind of capitalism, is that there's always going to be a kind of race to the bottom on kind of price, and we've got there basically in my setting in magnets. We definitely got there in terms of the price that manufacturers are used to paying for magnets. So we work quite closely with magnet makers, for example, in Europe, and they would say it's not feasibly possible for them to make magnets at a price point that's equivalent to the Chinese product. So all their customers, the OEMs, are going to continue to buy the cheapest compliant product they can get their hands on, unless there's some compelling reason not to. And that compelling reason could be internally driven. So there could be a kind of a decision on a risk basis that they want to onshore production capability or something like that. But the reality is that the supply chain doesn't exist at the scale required in order to service everyone's needs. So there's a fear that a move to a European supply chain gradually it might not be possible because the supply that they're used to might not be available anymore. So I think that the way we get there in terms of increasing the amount of material that flows through a circular supply chain has to be ultimately driven by demand from customers. And customers could be in the literal sense, from automotive perspective, for example, as in, how much are you willing to pay for a car in the forecourt? Will you pay an extra 20 quid if it means it's got, recycled magnets in it or whatever? Unlikely to be something that people are going to be that interested in. So I think the more kind of feasible thing to do is to try and appeal assertively to the OEMs to look to adopt a more robust Western orientated supply chain, which in turn enables a circular market to exist. In the UK, we're really well primed to do this, especially in wind, because there's such an early adoption of wind technology. That there's definitely a lot of material that will become available over the course of the next decade. So, we really want capacity to retain that in country and process it in country and get the full economic rent of it in country rather than lose it. Realistically, for the sort of ongoing sustainable commercial circular economy to work, there has to be a drive for that part of the supply chain. I think the customer. Quite how that's implemented is, another discussion. But I think kind of some incentivization of that offtake demand is absolutely key to this. Everything works backwards from there. That dictates how much magnets cost. It dictates how much the midstream cost. It dictates how much we can charge for the material that we make, and that dictates how much we can pay Bill and his team at EMR for the magnets that they recover. And ultimately, from their perspective, that'll be a value decision. Do we recover the magnets or not? And we always want the answers to that question to be yes.
And Bill, I guess it'd be good to get your side of that.
Yeah, no, really interesting. Tom saying that, so I agree with most of this. But I think, I've always sort of linked circularity to good economic business sense. I really don't think that the regulations are really an issue here. I think we sort of have a supportive framework. I think the difficulty we've got really is kind of moving from, as I say, sort of more of a linear-based economy into a circular one. So that's not easy with a lot of materials, and then it's, we're quite immature in terms of parts remanufacturing, refurbishment. I feel like we're a bit of a tipping edge, but maybe the efficiencies aren't there. But I think the sort of key thing that we see is gathering the information, prior to decommissioning or repowering, understanding the opportunities that you have, and then being able to actually plan for those circular strategies. And it may well be that you have to go down a recycling route, but you can consider other options. What we sometimes find is that people will come to us and say a turbine's coming down in a couple of weeks. Can you give us a price? And the only price they'll get at that stage is a probably distressed recycling price. So you'd kind of argue from both a value and a materiality perspective, we've lost opportunity there. So I think it really starts with early preparation of information and then engaging around a plan.
No, fab. That's good. I see there's one more question that's come in on the Q&A, and that's around what percentage of the value of a decommissioned turbine comes from the rare earths and the magnets. I don't know who wants to try and take that one.
I'll have a bash at that, right? So that's not an easy question to answer because every wind turbine is different. Every turbine has a different kind of the way they operate, the way they're designed to operate will determine how much magnet material is inside them, and that'll determine obviously how much it's worth. And then obviously within the magnet as well, every magnet is different. So just to make things more complicated, not every magnet is the same composition, and that will determine the value as well. But what I would say from a mass perspective, we think the magnets represent something like 1 to 2% of the mass of the turbine. And then in terms of the overall value, I've seen different figures in response to this particular item. Some are 10%, some are 30%. The old figures, I think 10% may be slightly outdated now because the value of rare earths has gone up so much. The NdPr price alone has doubled in the last year or so, and then the heavy rare earths, which are prevalent in offshore wind turbine magnets, certainly some of the earlier ones anyway. In terms of dysprosium, that's trading triple the Asian metals index price in Europe at the moment, and it's the same for terbium. So the value may be increased beyond that, but in terms of the sort of value per unit mass in a wind turbine, I don't think there's much in a wind turbine that would be higher than rare earth permanent magnets. But from in total, I would suggest that probably the copper and things like that are going to be a big revenue generator as well. Sorry, Bill, if you might disagree completely. It all depends on the composition and the number of magnets. It's never a straight answer, unfortunately.
And I think you're right, Tom. And I think it's actually getting them out, isn't it? And I think there's the challenge, isn't it, in terms of how do you access them, how do we prepare the activities, the space that we need to do that safely, and then make sure that the ultimate the value that we hope we're going to return to you is actually realize. So neither of us are taking a big risk. But look, it's a pathway we're actively exploring, and I think the more we do this, the more we'll learn and the more confidence we have.
Yeah, the follow-up question from Felix, sorry, there is assuming no resale is based on recycling outcome. So presuming that means like how much we can pay EMR for the material. And yeah, that's broadly consistent with I think what Bill and I have both suggested there, I think.
Perfect. And I think that probably brings us to a nice close point there, as we've got no more questions coming through. So with that, I'll just do a quick sort of wrap up. So thank you to everybody for joining us today. It's been really interesting, and thank you for your questions. I think it's great to have a discussion around some of these topics and get a little bit more of that sort of industry perspective. As I mentioned earlier, the session will be recorded, and this will be sent round following in an email following the sort of end of this session, along with the slides. So yeah, please do have a chance to have a look at that as well. So I think that's everything from us, and I hope everybody has a good day.
Thank you.
Thanks, Kerry.
Thank you.
Bye.